Hello and welcome to another PEPS Opticam Classic Quick Start video. In this video, we will be adding tapers to these three profile figures. After you have created your profile figures, you can go and create your machining. So we will go to our machining menu and then click on Standard Profile. Here we are just creating our operation sequence. If you have any questions about your operation sequence or creating profile figures, please refer back to our Exam 1 video of the Quick Start Guide. For here, I will just create a new billet. Just selecting my opposite ends. And then adding a thickness. And then the next few pages, I'm just making sure that I have my my positions are looking to be in the correct locations, as well as checking my plane heights. Okay, so now we are finally at the standard profile dialog. The first thing you'll do here is select your profile figure that you want to cut. All right. And then we will select our technology. For this example, I'm using the Makino post, so I'm using the Makino technology here. I'm just going to use high precision and 3 passes. Okay. So after I've selected my technology, I can select from 3 different taper controls. For this example, we will be using a different taper control for each shape. So you have your die face up, die face down, and constant incline. For the circle, we will be using the first taper control. So under angle, I will put in 5, and notice that our reference height here is at 0. Okay, so let me go to my setup here and make sure that my settings in here are correct. I have my tagging, okay, and then from here I can kind of just click OK. So OK here and then OK again. Okay, I'll rotate my drawing around, and you can see that we've added a taper here. So with the reference height set at 0, that is where we are holding or maintaining the size of our profile figure. So smaller at the bottom and 5 degrees larger at the top. Okay, so if you are going to hold the size of your profile figure at the top, you would change the reference height to 1. And then now I can click OK. All right, and now it's smaller at the bottom, and then the size of my figure is maintained at the top. When you do something like this, you have to be careful about your lead-off distance here. After it makes its full pass around, when it leads off of your profile, it will straighten out the wire. So if that lead-off distance is too small, it may straighten out the wire and cut back into your part. So you have to be really careful with this when working with tapers. So if this was my setup, I would need to go back and change my lead-off distance here to something larger. Or if you leave this blank, it will use the same distance as your lead on. So it'll just lead on with this distance and then lead off with the same distance. Okay. One more thing to add to this is for the AC Vision machine or post, this number here will actually be calculated from the top of the block down. So it will either be 0 or a negative number. So let me open up the post for this so that you can see. So you can see here the angle is still the same, but the measure height or reference height in the other post, for the AC Vision, this is calculated from the top down. So this number will always be a negative number. Okay, so let me go back, and then we'll click OK again, and you can see here this is our taper for the circle. All right, so we'll go ahead and create another standard profile for our square, and then click OK. And then for this one, we will be using the second taper control. I will also add 5 degrees to this, and our reference height will also be 0. So I'll go ahead and click OK there. All right, so we'll rotate this around just a little bit. So on this one right here, a couple of things to keep in mind. Once again, our leadoff distance here is a little bit too small. Okay, so we will need to increase that value, but also the square here has line arc line geometry, and notice what's happening here in the corners. So the upper and lower radii here are the exact same. So sometimes this is not possible. In that case, you will choose a different corner mode. Okay, so we might use conic square instead of iso square. When you do this, one of these will be a little bit larger than the other. For this part, for this direction of taper, it does not really work, but I can always change the direction, and you'll see how that changes. Okay, so you can see here now the radius of the upper is larger than the lower. Okay. All right, so a few things to keep in mind when working with line arc line geometry and adding tapers. So once again, I'll go back in here and make a change to my leadoff value so that it does not interfere or cut back into my part. Okay, there we are. Okay, and the last taper control is our constant incline. So I'll go back to standard profile again, select my profile figure, and then select constant incline. So for the constant incline here, there are 2 different ways of defining this angle. Right? One by displacement, which means distance in the x or y or x and y direction that the shape is basically shifted in. Okay, the other is a component angle. All right, so for this one, I will put 15 degrees in here, and you can see when I click, once again, let me go ahead and also go ahead and remove that, and then click OK, and we'll see how this differs from the other 2 tapers. Okay, so I'll rotate this around. You can see now our edges here are all pointing in the exact same direction, 15 degrees. Okay, so there we are. All right, so if you needed it to taper in the opposite direction for this, you can just put in a negative number and it will taper in the opposite direction. Okay, so now you can see this is leaning towards the right side. Okay, so hopefully that helps, and you will be able to add tapers to your programs. If you have any other questions, please contact us at support@optisolutionsUSA.com. Thank you.